Hello and welcome to Office Hours with Bill Jennings at Klamath Community College. We're back one more time talking about transformations of functions, and today, or this video, we're going to focus on order of transformations. So it's going to become very important to us. We've learned each of the individual transformations one by one. Now we're going to apply them, and order is very important. It's just as important as the order of operations. Well, it actually is the order of operations. So the first thing we want to do is look for horizontal shifts. Those are things that happen inside of a function. So an example might be if we had something that looked like x plus 2 squared, or the square root of x plus 2. That's something happening inside the function. Then if we have a multiplier that happens outside the function, so something like 2 square roots of x, it's a doubling. Whatever the result was, you double it. Then we end up with a negative transformation, which is, what I want you to think about here is this negative against the result. So whatever was positive is now going to become negative. And so it's an x-axis reflection. It's an output adjuster. So it adjusts the range. If you had a range that was positive, it now becomes negative. And so your range rotates, if you will, or reflects around the x-axis. And yet I know it's the y values that's changing, but the y values change if you reflect it around the x-axis. So that'll be a reflection across the x-axis. Now we've got a reflection across the y-axis. That is if you have a negative inside. So the perfect example here is the square root of a negative x. You can't put a positive number in. It's got to be a negative. So when you had this square root that looked like that, my domain has completely shifted. My x's that were positive now have to be negative. So it has to be a domain shift, and that rotates or reflects around the y-axis. Then last but not least, if I have a shift that just says, hey, add a constant to the end of the function, I'm just going to shift the graph up and down. Positive going up, negative going down, which is going to be the opposite of what's going on if we happen inside. So let's look at 1 or 2 or 3. But actually first, let's go ahead and get this out of the way so we can see what's going on there. And then what we're going to do is let's take that list and let's put it up here so we can save it and we can refer to it as we go down the list. So coming up here, I've got the x squared plus 3. What I want you to first to identify is the parent of the graph. The parent of the graph is an x squared. And then let's do the order. Is there anything happening inside? Nothing's happening inside. Is there a multiplier after the fact of the squaring? No. Is there a negative living someplace that I need to pay attention to? Well, there is a negative here. It goes with the negative 3. It's on the constant on the back end. So I don't have a negative living out here around this function. I'm okay with that. So then finishing up at the very end, I do have this plus or minus 3 going on, and so that's going to then just be a downward shift of 3. So if I have a parent graph of x squared, I'm just going to take all the outputs and just shift them down 3. That's where we're at. Now, coming over here, I have the absolute value of x. I'm going to take the absolute value function. I have none of those inside transformations. I don't have a doubling or a halving, and I don't have any negatives flipping things around. But what I do have is at the very end of the day, a plus 1. So I'm just going to take that graph and shift it up 1. Whatever the result was, go up 1. And coming on down, still referring to that list up there for you, if you have the square root of x minus 2, we're going to have a square root of x. That's our parent graph. And I want you to focus on the fact that that negative 2 is happening after the fact, so that's going to be a down 2. Now we're moving into something that we got to actually kind of start paying attention to. All the ones right before us were just really no different than our homework. It is kind of coming at us. Now we've got a double transformation, and order is going to be really important. You have to start inside the function first. That's kind of like order of operations. You start inside the parentheses. Inside, I've got an x plus 1 going on. Now this x plus 1 is going to be a left shift 1. Now the reason why it's a left shift 1, remember, x plus 1 has to be able to get back to a 0, so to speak. And the piece that would get us back to that major point would be if x was be equal to negative 1. And so that's why it's a left shift 1. Now, paying attention to the little details here on the outside, that negative. So again, looking at my order, I worked from the inside. I looked for a doubling or a halving. I didn't have any of those. And then now I'm going to look for this reflections. And so this negative on the outside is a domain mover. So what was positive is now going to become negative. So I end up then with this x-axis reflection. So an x-axis reflection in the end. Now, let's look at another one. We've got the square root of x. Okay, square root of x. That -2, does it live inside the function or outside? Inside. So it is a domain shift. And that's actually going to move me right 2. Again, if you put a +2 in here, that's actually going to be the square root of 0. That's your major point that we're going to graph from. And we got some graphs coming up here in just a minute. So if I had the square root of x negative, I got a square root of -x minus 1. So again, square root of x is my parent graph. Let's focus on that negative. That negative is happening inside the function, so that's a domain mover. So my domain movement is, if you add a positive, it's now going to become negative. So this is going to be a y-axis reflection because I'm shifting my domain around the y-axis. Then, at the end of the day, I'm looking for a -1, which would shift me down 1. So if I could graph the square root of x, I would rotate it around the y-axis, and then I would move it down 1. Coming down here, we've got more square root functions, so this square root of x. Now, notice the difference. This negative is outside, so that's a range movement. It was a positive output, now it becomes a negative output, so this is going to be an x-axis reflection, and then at the end of the day, I'm going to shift this guy down 1. One more square root function going on here, square root of x. Ooh, this guy's kind of a good one. This is the one where if you don't apply the order in correct fashion, we're gonna mess it up. So order says look for a left-right shift first. So the left-right shift says we're gonna move it left 1, and then this negative here, again, the negative is happening inside, so that tells me it's a y-axis reflection. And we're good to go there. How about this guy going on here? We have this here. We've got, this is going to be x squared. X squared, well then the -2, so this is going to be a right shift 2. And that 2 on the outside says, whatever your output was, we're going to double it. If you went right 1, up 1, we're going to still go right 1, but instead of going up 1, we're going to go up twice as much to 2. And that'll come together. Let's go do some graphs and actually watch how it comes together on graph paper. Okay, so now we've got our graphs ready to go. First, it's just the exact same thing we just did, but just now let's put it, actually, we've just talked about the parent and the transformations. Let's actually just move them around and make them come together the way they should. What I want you to focus on here is this first function, x minus 2, quantity squared, that's an x squared. I have an x squared going on. I have something right here in this body that's being squared, and so then I can just pull that up and square it, and I just have to look at those transformations to see what's going on. So I have a parent that's x squared. So my parent graph, I'm looking for something that looks something like that, because that's my parent graph. Now let's apply these transformations. This -2, I'll say it one more time, x minus 2, how does that go to 0? X minus 2 goes to 0 by saying x equals 2. So you could say major point has moved over to here. That's where it has to go. That makes it a right shift 2. That's what happens inside the parentheses, not on the outside. The outside works just straight up. After we've moved it to the right 2, what do? We now take this guy and move him down 1. So what do we have? We've got a right shift 2, down 1. Major point has been relocated. My behavior matches right up. From major point, I go over 1, up 1. I go over 2, up 4. And you can kind of see why we spent so much time talking about behavior from major point. So now I end up with a graph that looks something like that. We could have potentially, right from the start, listed these transformations like we did on the previous page. When we listed those transformations on the previous page, we said, okay, move to the right 2, which I guess when you look at it, it'd be going this way. Move to the right 2, and then move down 1. We could have just maybe just grabbed our original parent graph and said, okay, let's move you right 2, and let's move you down 1. And if I'd drawn really good graphs, those would have lined up just perfectly right on top of each other. So you can visually see exactly what's going on there. Okay, Moving on, we've got a square root of x. So I've got a parent graph that's the square root of x. Let's go ahead and look and see what that square root of x graph would look like. In our mind, we should see something that looks about like that. So that's what our square root looks like, with my major point being over here at 0, 0. So let's talk about our transformations. Transformations starting on the inside, x plus 3. That is a left shift 3, because at a negative 3 I'll get my 0 back. So I'm going to take and move this left 3. Now I'm going to go ahead and move everybody over 3. 1, 2, 3. So, and a 1, 2, 3. So I end up with my graph looking like that after I've moved it left 3. Now, this negative that's happening on the outside telling me, hey, you had a bunch of positive outputs. After you get those outputs, apply a negative to it. Everything's going to go across the bottom. So we're going to end up with, at the end of the day, my major point's going to stay right here, but instead of being up on the top, everything is going to rotate around that y-axis. And so I'm going to end up with this guy being my final answer. So let's get this stuff out of the way, and you can actually see my final answer there. So what did we do? We moved left 3, and what was positive became negative, and everything moved out just fine. Okay, x to the third. Now x to the third, so I've got an x to the third graph, and I want to start with anything inside of the x to the third function. Is there anything going on inside that x to the third function? Nothing is happening there. Is there a negative that's happening outside? Yes. Now, because it's an odd function, we could have got lazy here. It would work either way, but let's do it right. The negative is outside. So the negative that's outside says whatever was positive now becomes negative. So we're going to have this x-axis reflection. I could have actually written that. I should have probably written that here. X-axis reflection that happened. Well, this is where I'm going to start with x to the third. So I'm going to take my parent graph that would have been 2, 8. And again, this time in my demonstration of this one, I'm using square graph paper instead of rectangular skewed graph paper. So my graph actually shows the true shape of this and being pretty steep. So I have this. Now, this x-axis reflection, what the major point stays right here, but this guy then now goes down here, and this guy becomes down here, here, and here. So I end up with, after I've reflected it, it looks like this. Now, let's focus on the back end. There's a plus 2. So after I've gotten to this point, I've created the red line. Now everything needs to go up 2. So if I could just bring everybody up 2, conveniently located there, and we end up with this graph. It's going to go down, and those wouldn't have touched, but we'd get the idea of how that's going to come together. So that's what we end up with on that graph. Looking here, we have more to focus on. I want to talk about the fact that I have an x squared graph. So x squared, I'm going to become very proficient at this. Well, I'm proficient at it. You're going to become very proficient at it, of identifying that that's an x squared and it's just a parabola, and let's just get the base guy right on down. So once we've identified that base, we're going to start on the inside. On the inside, I see a right shift 4, because a positive 4 is where I get my 0 back, and so everybody is going to shift over here to this point here, and coincidentally matches at that point, but nothing to do with anything, just as a right shift 4. Now, once I've moved it to the right 4, I want to focus on the fact that I have a double. Now, the double, and notice I'm focusing on the double first, so I double everything. So my doubling says from major point, I have a major point that's here, and I used to go over 1 and up 1. I still go over 1, but instead of having a 1 output, I now have a doubling, so it's going to be twice as high. And so when I went back 1, I went there, and now I'm going to double that. And when I used to go to the right 2, I still go right 2. It used to be right 2 up 4. Now it's going to be right 2 up 8. So I'm going to be like, well, I guess it is right there on the edge of the grid. And then I'd go left 2 and up 8. So I would be here, coming down, major point stayed there, and we're doubling that output. So it's not a shift, it's a doubling because the major point stayed right where it was, but I went over 1, up 2 instead. After that is done, I have one more transformation to hang on to, and that's the negative sign, because it wasn't just they were all positives, and that negative now applies to make everybody negative. So I'm going to end up with an x-axis reflection. Again, that negative affects the output, the final value output, which is the range. And so the range that was positive now becomes negative. So I need to take this whole graph, and everybody that was above now becomes below. So I've got these points that are reflecting around that, so we end up coming down and looking just like that. One more here with our square root function. So we've got the square root of x, so we saw that as being this guy here. Let's get him going. We have this guy looking like that. That's our square root. I now have an x plus 1. So x plus 1 is going to be a left shift 1. So everybody moves back 1. So we end up with a graph that looks something like that with our green. Now, let's get that blue line out of the way so we can let's get that green line nice and fresh there so we can actually see where we're at and what's actually going to happen here. So I've got this nice line that looks like such. Now, the very last transformation is this 1/2. So remember what we had with that doubling. It said you still from major point have the same behavior, but then you just cut it in. We doubled it on the last one, and this one we're actually going to cut it in half. So what we had going on was an over 1, up 1, but we're going to cut that in half and only go half tall. And then over here, we used to go from major point, we went to the right 4. The left and right major point movement doesn't change, but then how far up the graph you go, we're going to cut that in half. We used to go over 9 from major point and go up 3, but we're going to just go up 1.5 to make it come out at that point. And we're just going to let that guy go right there. Now let's take a look at what would happen if someone handed us a parent graph that we'd never seen before. This could be defined as being an f of x, and that would be fine. If someone came along and said, hey, let's do f of x plus 2, where x plus 2 happens to be inside the function. All we're going to do with this graph is we're going to take and shift him left 2. Again, remember, it's happening inside the function. So everything on this graph would just move left 2, and we'd end up with a graph that would look something like this, and we would be good to go. Is it possible that we could have taken this and said, okay, let's find f of x, and let's do a plus 3? That's an after the fact. Everybody would just shift up 3, and that's all we would have to do there. And we would end up with a nice little graph that would look like that. Is it also, that should have been up 3, sorry about that. That would go there. Is it possible that we could have done a double transformation, and it is perfectly feasible that we could have, and that could have been something that would look like x plus 2 plus 3. We could have said, okay, we'll take each of these points, and what we're going to do is we're going to then go left 3, and then we'll go up 2, and we could just move them as such. So I would get this. I wanted to go left 2, up 3, and then I wanted to go left 2, up 3, and I end up with this guy, and so I'd end up with my graph that looks like such. And there we would have it. So that would be how that would all come together. Hope you enjoyed the video, and we'll catch you the next time on Office Hours.